This is Daniel Chin, and this is my extra credit video. And if you're hoping that this video is going to be as interesting as the introduction, then you're going to be severely disappointed. So, I attended the lecture by Dr. Morris on pattern formation in nature and why the universe is not boring. So, basically, he goes over how the universe has organized and evolved structures that emerge from the simple laws of physics, and that these structures exist despite the universe's tendency to go towards disorder. Alright, so the main talking points of the lecture were that nature is constantly evolving and it hardly ever stays in balance. Nature tends to go for stability and instability, which is basically entropy, and not optimality or efficiency. The laws of physics apply the abstractions of mathematics to the real world. Finally, patterns are the natural consequence of these laws. For example, meanders can be explained using fluid dynamics, and this is pictured on the right. And I found the second point to be particularly interesting because it explains why the river is not just a straight line. Alright, so the main thing that I learned from the lecture was that patterns in nature can be broken down into basic physics or math principles. So pictured here are Bénard cells, which are the result of convection. This is the shell of a nautilus, which shows logarithmic growth. Here's a snowflake, which is a really good example of symmetry. And then these are ripples in sand that are an example of mechanical waves and the transfer of energy from the wind to the sand. Alright, so finally, I just did a little more research into meanders, which are bends in rivers that form as water flows around them. So as soon as the path is even slightly curved, more and more sediment is dragged to the inside of the bend. And due to the conservation of angular momentum, the speed on the inside of the bend is faster than on the outside. Erosion accelerates, which further increases this curvature, and this is an example of a positive feedback loop. And finally, towards the end of its life cycle, the curve completely breaks off and forms an oxbow lake. So I'm just going to leave you guys with a video that's kind of like a time lapse of how these meanders form.